Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve questions from sample paper number 7, BALI navigation book. Let's begin. Question number 41. The failure of a radio altimeter would result in what? Result in warning of proximity to the ground being not available during cruise. Increase the risk of CFIT, controlled flight into terrain, nothing but crashing with mountains. Both A and B are correct. So, radio altimeter works from ground level up to 2500 feet. Okay, and normally all planes cruise above this altitude, above this height of 2500 feet, 10,000, 20,000, 25, 30,000. Okay, so this radio altimeter is not designed to operate in cruise conditions. Radio altimeter is mainly designed for use during landing phases when we are much closer to the ground surface. So option A is wrong, Bravo is right. When radio altimeter fails, there is no other equipment that will give you a command or give you an alert, a warning that you are closing onto a ground surface, a mountain, an obstacle in front of you, below you. Alright. So when you don't have that extra help or any supplementary equipment to aid you, to help you in easing your workload. So the chances of CFIT, controlled flight into terrain or crashing, increases. Okay. So option Bravo is the right one. It increases the risk of CFIT. 12. What does the best angle of flying speed achieve? So there are two speeds. Best rate of flying speed Vy, and the second one is best rate of flying speed, best angle of flying speed correction, Vx. Now, best rate of flying speed, which is Vy, when you fly at this particular speed Vy, you will climb a particular altitude or height in least amount of time. In least amount of time. You are flying at a particular angle, Vx, best angle of flying speed. You will climb to a particular altitude in least amount of distance. In least amount of distance. So why is this best angle of flying speed used? Let's say there is a ground, this is your runway, and just in front of, at the end of your runway, there are trees, mountains, like this. Okay, basically there are high obstacles at the end of your runway. Now when you take off from this runway, your first job will be to, your first job will be to avoid these obstacles and fly above them as soon as possible. Okay, now you don't have much time or much distance between the runway and these obstacles. So your purpose, your mission will be to climb the highest altitude in the given distance. So at this point of time, you will be climbing at a speed called Vx, best angle of flying speed. This speed will enable you to achieve your desired height or altitude in the least amount of horizontal distance. Okay, so best angle of flying speed is used to avoid obstacles. To avoid obstacles. Best rate of flying speed will be used in other scenarios when you do not have any obstacles in front of you. So you can use best rate of flying speed so that you can achieve your target height in least amount of time as soon as possible. Okay. So what does best angle of flying speed achieve? Maximum rate of climb, provides maximum vertical climb rate without sacrificing too much forward progress, meaning forward horizontal distance. Efficient climb in terms of fuel consumption. So option B is the right one. Maximum vertical climb, maximum vertical climb without sacrificing much of horizontal distance. Option A is wrong because they are talking about rate of climb. When we talk about rate of something, there is a time factor involved. How fast you are doing that thing. Okay, so option A will be the wrong. Charlie will also be wrong. So you can see here, when we fly at Vx speed, we get maximum gradient. That means maximum height with respect to horizontal distance. When we fly at Vy, we get maximum rate of flying. That means best vertical speed. And this is the normal flight. Okay, next. The LMT and date at a longitude 1 degree west is so and so. What is the LMT and date at 159 degree east longitude? So let's say this is the horizontal representation of your Earth. This is your prime meridian. 1 degree west. So 1 degree west will be in the western hemisphere. 159 degree east. The local mean time at 1 degree west is 1330, 6th of Jan. Now what will be the local mean time and local date at 159 degree east longitude? Now what is the d long between them? The d long between these two longitudes is equal to 1 degree plus 159 degree, that is 160 degree. Now we know that east longitudes are ahead in time with respect to or compared to their, their western longitudes. So now here 1 degree west is to the west of 159 degree east. That means the timing at 159 degree east will be ahead of the timing at 1 degree west. So it will be more than 1330. So by what amount? So the formula will be local mean time at east longitude will be local mean time at west longitude plus the difference between them, d long divided by 15. So LMT at western longitude is 1330. D long between them is 160 degree divided by 50. So 160 by 15 is 10 hours 40 minutes. 10 hours 40 minutes plus 13 hours 30 minutes is 24 hours 10 minutes. Now, in a particular day, we have maximum 24 hours. So we cannot have 24 hours 10 minutes. So this will be equal to 0010. And the date will be the next day. So the next day is 7th of Jan. Okay. So this is your answer. Next. Aircraft is said to be neutrally stable if a center of gravity is located at forward limit, aft limit, aerodynamic center. So correct answer is option Charlie. ILS and global navigation satellites are to be written in flight plan as what? So ILS is written as Lima L. Global navigation satellite is written as G. Okay. Next. GPS constellations are typically deployed in our orbits that are inclined relative to Earth's spin axis, equator, prime meridian. So all orbits are inclined with respect to the Earth equator. Which of the following combinations give least performance? High humidity. So your density. Now the density in air is controlled by three factors. Okay, it's controlled by temperature, humidity, and the third is pressure. Okay, so least performance. Now least performance will be given by a low density or less density air. When the density of air is very little, so the air will be thin, and this thin air will not enable the engine to produce high power output or high thrust. Okay, so under what conditions can we expect to get little density air, thin air, less density air? So whenever temperature increases, the density of air decreases. Whenever pressure decreases, no pressure, again density of air will decrease. Whenever humidity in air increases, density of air will again decrease. So, high humidity, yes. Low altitude. Now, when you are flying at low altitudes, atmospheric pressure is more compared to pressure at higher altitudes. So, we need lower atmospheric pressure to get a lower density, less density air. So, this is wrong. So, option alpha wrong. High humidity, yes. High altitude means lower pressure. Lower pressure means low density, yes. High temperature means low density, yes. So, option Bravo is the right answer. During a VFR flight at a navigation checkpoint, the remaining usable fuel is 60 US gallon. During a VFR flight at a navigation checkpoint, the remaining usable fuel is 60 gallon. The reserve fuel is 12 gallon. According to the flight plan, the remaining flight time is 1 hour 35 minutes. Calculate the highest acceptable rate of consumption for the rest of the trip. Okay. Now the rest of the trip is 1 hour 35 minutes long, and the fuel available is 60 US gallon. 60 US gallon. So what should be the, you want the 60 US gallon of fuel to last for 1 hour 35 minutes. Okay. So what should, usable fuel is 60 US gallon. Reserve fuel is 12 US gallon. Now you're not going to use reserve fuel for your flight. Okay. So flight fuel available will be equal to 60 minus 12 is equal to 48. Fuel consumption equals to flight fuel divided by time. 48 divided by 0.135. So 48 divided by 1 hour 35 minutes is equal to 30.3. So you can have a maximum fuel consumption rate of 30.3 US gallon per hour. Okay. So that is the answer. The operating mass of an aircraft is DOM plus takeoff fuel, empty mass plus takeoff fuel, empty mass plus crew plus baggage plus catering. So option alpha. So remember this. You start with basic empty mass. When you add variable load to that, you get dry operating mass. Variable load includes crew baggage, food, water, catering, etc. When you add takeoff fuel or fuel on board to dry operating mass, you get operating mass. When you add payload to dry operating mass, you get zero fuel mass. When you add payload to operating mass, you get takeoff mass. Similarly, when you add fuel to your zero fuel mass, you will get takeoff mass. So there are two ways to get takeoff mass. Add payload here, add fuel this side. Another way to get takeoff mass is DOM plus useful load will give you takeoff mass. What is useful load? It is a combination of takeoff fuel plus payload. That is your useful load. So here they are talking about operating mass. So operating mass will be DOM plus takeoff fuel. Next. Coded identification of VOR is transmitted every seconds, every 30 seconds. Okay. The coded identification of the VOR is transmitted about every 30 seconds. Okay. So you will hear this VOR identification thrice every 30 seconds. So this concludes our lecture. I hope you have understood all the 10 questions that I have answered in this video lecture. Do watch other video lectures in which I have solved questions from other sample papers. from other theoretical chapters, Oxford, Keith Williams. Explore my channel, you will get lot of educational content. Best of luck. Solve this paper again. Solve all the questions without looking. Set a timer too. I request you all to subscribe, share this video lecture with your friends, and hit the like button if you have liked this video lecture. See you.